Good morning. Today I will start the lecture on pump, especially fluid machinery, which will be delivering fluid from one point to another point or increasing pressure for your fluid machinery application. So that machinery application can be in your marine engine systems or your refrigeration systems or onboard cleaning operation. You need lots of water. Okay, and before I start, actually you have to understand what is pump. Pump, actually you are adding energy to fluid. Okay, and one of the oldest pump, you can see this human heart. Okay, and if there is any animal living more than say 100 years, 200 years, so that will be the longest one actually. I think some turtle, they live several hundred years, so that can be as the longest working pump without any failure. So if something is failing, if pump is failing, that means your life is gone. So you have to consult immediately to Apollo Heart Center. uh, and in contrary, turbine actually fluid giving energy. Fluid is giving energy to machine. Okay, so pump example, human heart is one pump example. You are giving mechanical energy. Okay, your body is working and you are delivering fluid. Fluid means blood to your whole body from brain to your toe. And if you see turbine example, will be like wind turbine. Okay, uh, or maybe tidal turbine, or many other type of turbine, gas turbine, steam turbine, or nuclear power system will be, I'll be teaching later. So there also they will be using some turbine. Okay, so turbine is having application on your shipping machinery or option machinery. Similarly, pump is also having application on your shipping machinery. Pump will be used for your boiler feed pump application. Pump will be used for your refrigeration system application, pump or compressor. Pump will be used for delivering liquid or water from sea surface to your deck for cleaning and other operations. So there was ample applications are there on your shipping machineries or offshore machineries. So in this lecture I will discuss in details about pump and turbine. And pump you have already seen, actually human heart one example. Another is that like Indian rural areas, people will be getting water using hand pump. uh, in your hostels also you are getting water on your building, top of the building. Okay, some tank will be there, right? uh, so that tank will be filled using some pump. Okay, pump will be installed at the bottom and it will be delivering fluid to the top. Okay, so that means some electricity or some energy will be required to deliver the fluid to the top, because you are increasing static head or pressure of the water, so that water will be reaching to the tank height. Okay, so you are giving energy. Okay, and how you are giving? You are giving, maybe you have IC engine, internal combustion engine. So internal combustion engine, what is internal combustion engine? It is like you have truck, bus, train, tram, everywhere there will be some internal combustion engine which will be giving power. It will take diesel or petrol, some fuel, and it will give power. Even in marine machinery also, ship engine, so there will be internal combustion engine, so that will be giving power. So that power will be running some pumping system to deliver fluid from one point to another point. Okay, or maybe electric motor. Okay, sometimes IC engine will be giving power, sometimes electric motor will be giving power. In many cases electric motor will be giving you power. For example, in a hostel application, everywhere you cannot put IC engine separately, it will be very much noisy. So there will be a small motor, small or big, based on your requirement. So that motor will be giving power to your pump, so the pump will be delivering fluid to another place. So pump will be giving energy to fluid. Okay, so that after that fluid will get more static head or dynamic head. Head means pressure. Actually, in fluid machinery system we see, we specify pressure as a head. Okay, head means equivalent of water column height. Okay, equivalent of water column height. Okay, for example, if I say head 10 meter, 10 meter means your pressure will be 10 H rho g, that means 10 into water density 1000 into 9.81. Okay, this will be your pressure in Newton per meter square. And whenever you are studying this pressure head, you have to remember units properly. If you do any mistake in unit, then your whole calculation will be wrong, or understanding will be improper. So you have to remember how to convert unit from one unit to another unit, what are the different unit for pressure, temperature and all these things. If you have to recap every time. I may not teach all the units every time, but you should remember, as an engineer you should remember the units, how to convert it. Okay. So another thing is that propeller you have. Okay, in ship you will have propeller. Okay, some propeller will have, right? So propeller will be propelling a ship. So propeller will be coming under pump or turbine category. So if you see propeller, actually you are giving mechanical energy, you are delivering fluid. So fluid giving reaction, because of reaction actually your ship will be moving. So it will be coming under pumping category. Actually first you are delivering fluid, and fluid is giving reactive force, or third law of Newton. Okay, action equals is equal and opposite to reaction. Reaction is equal and opposite to action. Okay, so it will be coming, propeller will be coming under pump category. Okay, propeller category, pump category. Okay, so if I have one compressor, compressor will be also coming under pump category. So pump will be like propeller, compressor. You have blower, you have ceiling fan. Maybe in summertime in India you will have ceiling fan in your hostel room or your houses. So that will be coming under pump category. Okay, pump means you are giving energy to the fluid. Okay, propeller, compressor or fan. Okay, and turbine, turbine you will have wind turbine. Already I have given example, wind turbine, tidal turbine, gas turbine, steam turbine. So many types of turbines are there. So that will be under turbine category, means you are giving energy, you are taking energy from the fluid. Okay, energy, wind turbine, wind is giving energy to machine and then you are converting to electricity. Okay, so that will be coming under turbine category. So I am dividing into two category, one pump, one turbine. Pump taking energy from machine, giving to fluid, and turbine just doing opposite work. So I said there are two type of machine, one is pump, one is turbine. So let's start with pump. Okay, later we will discuss about turbine. So pump, basically there are two type. One will be positive displacement type, another will be hydrodynamic or hydrokinetic or kinetic pump. Kinetic pump. Okay, so positive displacement pump means it is taking certain amount of fluid, it will be delivering the same amount of fluid. Okay, in hydrodynamic or kinetic pump, in that case actually you are giving centrifugal force and that force will be delivering or giving energy to the fluid. Okay, so one positive displacement pump example, your human heart. Okay, and that is reciprocating type. Okay, so that is human heart is actually reciprocating type. Another will be rotary type. Okay, I'll be showing some example. So reciprocating type means like human heart giving pulse, right? So one time it is taking blood, again pushing, taking blood, pushing. So continuously it is doing like that. So that will be called reciprocating type pump. So your injection syringe you are giving, doctors will be giving, right, nurses. So that is also actually reciprocating type pump. You are pumping fluid to your body, right? You have seen cycle pumper, roadside small cycle shops will be there. So manually pumping system will be there. So there also you are actually pumping air, okay, or compressing actually. So I can say pumping, you are pumping air to your tube, cycle tube. So that is actually reciprocating type. Okay, one time delivering, again delivering, again delivering. So continuously you are giving reciprocating force and your tire is, or tube is getting filled, or tube is getting higher pressure. So you are increasing pressure there. And reciprocating type, again there will be many types, like one single cylinder, axial piston or multi-cylinder, many type will be there. Okay, single cylinder, multi-cylinder, then duplex, simplex, quadraplex. Okay, so many type will be there: double cylinder, single cylinder, axial piston. So many types will be there, reciprocating type. Okay. Now, if you go to rotary type will be gear pump, vane pump, lobe pump, screw pump, and diaphragm pump. Diaphragm pump will be coming at reciprocating. Diaphragm here, okay, pump, okay, and gear pump, vane pump, lobe pump, screw pump, single screw. Then again, screw pump will be a single screw, multi screw. Okay, so there will be many types of pumps, but all type of pumps may not be used for your specific application. But first, before you buy or install any pump for your specific application, you have to know what are the different types available, what are the criteria, design criteria or flow rate criteria or pressure criteria. Based on that, actually you are buying or you are using or you are handling when ship is working, right. Another is the kinetic pump. Kinetic pump actually rotary pump. One centrifugal impeller will be rotating continuously. So that type of pump will have three type, basically centrifugal, axial flow and mixed flow type. Okay, so centrifugal type actually, okay, centrifugal or radial I can say, okay, axial flow and mixed flow. Okay, instead of centrifugal I should write radial. Okay, I'll explain later. So pump will have basically two type: positive displacement, centrifugal or kinematic type pump. That is basically centrifugal pump. Positive displacement pump, it can develop very high pressure. Okay, so this pump, very high pressure can be developed, high pressure, but flow rate is low. High pressure, flow rate is low. Okay, Q is low. So I'll be using this symbol Q for flow rate every time. High pressure, P is high. Okay, but if you see hydrodynamic pump, there normally flow rate will be high, Q high, and H P is low. Okay. Now you got like for blood flow from whole body you have to deliver fluid, right? For small amount of fluid it must reach to your finger, toe, everywhere. So there you need very high pressure actually. So you are using reciprocating pump, pulsating. You are giving pulsating flow to your body, right? That's why this older days doctors were used to pressure this knob, this vein, and they will be measuring pulses of your heart, and based on that they will say, okay, fever is there or not. Okay, so this is called reciprocating system or pulsating system. But centrifugal type or hydrodynamic type or hydrokinetic type pump, that will have continuous flow, so that will not give any pulsed flow, it will be giving continuous flow. So reciprocating positive displacement type is actually pulsed flow. Okay, pulsed flow. Even doctor says like this is pulse. Okay, pulse flow, and this is continuous flow. This hydrodynamic is continuous flow. Continuous flow. Okay, now I'll show one impeller, centrifugal pump. In positive displacement pump, human heart, one biggest example. So I'll start with centrifugal pump. Centrifugal pump will have one impeller. This is called impeller. Okay, you can see this one, impeller. Okay, impeller will have lots of channels. You can see the channels. Okay, and it will be rotating at very high speed, and speed will be having that impeller centrifugal pump. Okay, impeller will have rotation RPM or revolution per minute per minute. Okay, maybe 1400 or 3000 RPM. Okay, or small RPM or capital RPM, whatever you write. 1400, 1500, 2000, 3000, 3000, okay, within that range. So not less than like 400 or 100, 200. It will be like 1400, 1500. So that high speed pump actually. So whenever it will be rotating at very high speed, this is called impeller. Impeller will be covered by one casing. Okay, this is called volute casing. So volute casing will be like this. Okay, impeller will be having, my impeller will be like this. Okay, and impeller blades, these are called blade. Okay, fluid will be delivered like this. Fluid delivery. Okay, so in your household application, your gardening or everywhere, you can see some small pump will be used there, continuous flow pump. So that flow pump actually is called impeller diffuser pump or volute. This is called casing or sometimes called volute diffuser. Okay, so what does it do? Impeller inside one casing, metal casing, this impeller will be there. So impeller, if you fill this area, this is called impeller eye. Okay, this area, this entry area of fluid, this entry of fluid, it's called impeller eye. Okay, so I'll draw like this. My impeller blades are like this. Okay, so this area is called impeller eye. Okay, you can see the picture I have drawn, and here actual impeller, you can see this area is called impeller eye. Fluid will be entering through the eye, and this hole actually, this shaft. Okay, my finger is working as shaft actually. When shaft is rotating, this motor will be there. Motor will be rotating this impeller at very high speed. When it is rotating at very high speed, so fluid will be, if this area is filled with liquid water maybe, so at very high speed that water will try to go out of the impeller, okay, because of centrifugal force. Okay, the impeller eye, and let's say this area water will be going out. Okay, okay, this is because of centrifugal force of water will try to go away from the eye. Okay, this is eye, and if you rotate at very high speed, water will try to go away from the eye. So because this area, whole area is closed, so water will try to follow the channel and it will go out. Okay, so and we have blades, these are called blades. 1 blade, 2 blade, 3 blade, 4. So 1, 2, 3, 4, 5. I have 5 blades in this impeller. I have 5 blades. Okay, so these are called blade. This is called blade. Okay, so I'm just making a little bit thicker blades. Okay, and this is called back plate. This metal plate is called back plate. Okay, this is called back plate. Okay, so one impeller will have one back plate, impeller eye, one hole for shaft, my finger is here, my finger is going to the hole. Okay, now shaft will be rotating this impeller at very high speed. Okay, when it is rotating at very high speed, water, if something water is there, water will try to go away from the impeller. Okay, so that they will follow the channel or this path. Okay, so but why this is like randomly cut? Actually, this is actual impeller. We cut this one just to show for show in class how this impeller blade and flow path looks like. Actual impeller is like this. Okay, this is made of softer material. So this is impeller eye, you can see. Okay, one shaft is there, shaft hole. Okay, this black I'm inserting, you can see this one is shaft hole, and if it is rotating at very high speed, water, if you have water pipe connection, so water will be sucked from here, and at very high velocity this sucked water will go out from the impeller. Okay, when it is going out of impeller, another casing is there, you can see this slide, when the casing is there, so casing will be collecting all the fluid and it will be delivering to other place. Okay, so this area will have one pipe connection, so this pipe connection will be called suction pipe. okay, because fluid will be sucked through this one. Okay, when shaft is rotating, impeller will be rotating, fluid will be sucked from this pipe, and if this pipe is connected to one tank, water will be sucked and it will be going out of this channel. If you see, lots of holes are there, okay, one blade, two blade, and fluid will be coming there and it will be collected in the volute. Okay, this is called back plate, this is impeller eye. Okay, opposite side you see different design actually. This is, there is no eye section. Okay, front side is having eye, fluid is entering, going out. So this plate is called front plate, this front side plate. Okay, in this case I have removed this one just to show you there is no front plate, I have only back plate. But in this case I have both plates. Okay, so it is creating one channel, closed channel. Okay, so one impeller, this is called closed impeller. Okay, whatever I am showing, this is called closed impeller because front plate is there, back plate is there. Okay, impeller blades are there and fluid is entering and coming out through this channel. Okay, this is called closed impeller. Okay, I am showing this one as a closed impeller. Okay, and there will be some open impeller also. In that case, front plate will not be there, back plate will be there, front plate will not be there. Okay, it will be looking like this. So that is called open impeller. Okay, if it is like here, I have removed the front plate. So if some impeller is looking like front plate is not there, only blades are there and back plate is there, that will be called as a open impeller. Okay, there are different applications for closed impeller and open impeller. I'll explain later.